Hi girls, I'm at home, so there's a lot of noise and dog barking, but I'm sure we'll live with that. Okay, exact value triangles. There are two triangles used in trigonometry to get exact values, of the sine, the cosine, and the tangent. These three angles are 30, 60, and 45. Those are the only ones we get exact values for. This will enable you to do trigonometry without a calculator, so you can imagine when you take a test someday where you're not allowed to use a calculator, these will be on it. I'll give that. They're pretty easy to figure out. So let me just start. The 30, 60, 90 actually comes from half of an equilateral triangle. So in these triangles, you know, every angle is 60 degrees. And when I drop a little height here, or a perpendicular to the bottom, this becomes 30 degrees, and this becomes 60 degrees. Okay? And basically what we do is we say, okay, well, I'll figure out the things, like let's say I let this be 2 on this side. I could pick any number I want, but I'm just going to let it be 2. Then this side would be 1, and I could use Pythagoras to figure out this side. So I'd go 1 squared plus, we'll just call it h since it's the height, plus h squared equals 2 squared. So 1 plus h squared equals 4. So h squared equals 3. So this is the square root of 3. So the triangle that we actually use, and I'll put it over here, the 30, 60, 90, is just half of that triangle, because that's all we want is 30, 60, 90. So this angle's 30 degrees, and this angle's 60 degrees, and this angle's 90 degrees. And it's always in the ratio of 1 to 2, square root of 3. So this side we could say is x units long, and this side across from the 90, the longest side, is double that. And this side here is x times the square root of 3. And we'll do an example using that, but that's what we look at right for now, okay? The 45, 45, 90 comes from, you know, this triangle, an isosceles right triangle. And, you know, if I looked over here at one of those, I'll just make a little one. And I said, okay, what if this side's 1 and this side's 1? They have to be the same because it's isosceles. I got 1 squared plus 1 squared, I'll call it c, equals c squared. So 2 equals c squared, so c is the square root of 2. So in these, no matter what the side is, could be any length, but they have to be the same. And this is that times the square root of 2. Oops, gosh, I'm off the page. Sorry about that. I'll just quick go over that again. So these sides are both 1. 1 squared plus 1 squared is c squared, so this side is the square root of 2, the hypotenuse. So no matter what this length is, that's that. All right, so let's just do this little table down here. So if we have the sine of 30 degrees, I go up to my triangle, my special right, and I go sine of 30 is opposite over hypotenuse. So it's x over 2x. And the x's just cross out, and I get 1/2. So the sine of 30 is 1/2. Okay? Now, you need to fill this out, and it's just, you know, I'll do another one with you. I'll do cosine of 45 with you, and then you can do the rest. Cosine of 45 is adjacent over hypotenuse, adjacent over hypotenuse. So that crosses out, and I get 1 on root 2. Now, I don't usually leave things like that. I usually rationalize the denominator, remember back from surds. So that's square root of 2 on 2. So square root of 2 divided by 2. So you need to get these other 4, and then check with myself or Ms. Gatera and see if you've done them right. Okay, bye.